People love these like balloons and circles and problems like this, I know. But the important thing is actually drawing the picture. And I know that they've been telling us to do that since high school. I did, for a time, not draw the picture. And so I will tell you that the before and after is pretty, draw the picture. All right, so I can't draw well, but you can see that this is my picture of the balloon. I'm doing number 60. It's similar to 59, which is your assigned problem. And then they're blowing up this balloon. So I'm going to get a bigger balloon later in time. So this is my version of a snapshot in time of two balloons. And I would expect that the radius of that sphere should get bigger if it's a spherical balloon. And they give me that. They say the radius of the balloon is increasing at a rate of 2 centimeters per second. So what that means is that, again, by units, I can see that. 2 centimeters per second times the number of seconds I'm blowing up the balloon is going to give me that radius in terms of seconds, because the seconds are going to cancel each other out, and I'm just going to be left with centimeters when I do this multiplication. So if I plug in 10 seconds, my radius will be 20. So that's a formula they're actually giving me here. So, wow, that's the first question they asked me. Express the radius of the balloon as a function of time in seconds. It was just me thinking. I never go to the questions first. I go to the problem and think about what the problem's telling me. And I get the answers right, and I get the answers quicker than someone who's just looking at the question that's being asked first. And I've actually run experiments with my sister with a timer to see who's first. And I always ended up first, and I always ended up right. And it wasn't because I have more education than her. It's because I'm reading the problem first and then understanding what it's telling me, and then I can answer whatever they're giving me. The second question they asked is, what is the volume of a balloon as a function of the radius? They wanted V composed with R. They just wanted my R plugged in for the formula of the volume. And so I did that. I just plugged it in. I plugged in R is 2T in for and that's going to square this. So I'm going to get centimeters squared here. And then in the end run, my total has to be centimeters cubed because it's a volume of a balloon. So that's all they wanted for the last part, is they wanted me to plug that in. And that is indeed a composition of functions, or a substitution of one equation into the other. That's really what you're doing. And so your problem is very similar. You have an area, you have a radius, again, it's increasing. You're given that radius as a function, so you can do the same thing, except your formula for area is going to be different than my formula for a volume. Where did I get this formula for a volume of a sphere? I just Googled it. So you can do the same thing if you forget.